Hello and welcome, my friends. It's your friendly neighborhood visual snow guy today, and I've got a quick video talking about the visual processing order. So, kind of a step-by-step process of what happens when you are trying to see something. And the question is where in this process did something go wrong to cause visual snow to exist? So we're going to focus specifically on the static today. The static is the number one symptom of visual snow syndrome, but also visual snow itself. It's the only symptom. So the question is where does the problem arise? Is it from the very first step of light coming in our eyes, or is it one of the very last steps of the brain top-down function of everything altogether? And all I want to do is I want to kind of take a chill approach and just kind of discuss it real quickly. So let's start off with just a very... Oh, and also, I just want to show this off real quick. This looks really cool, by the way, in this light. I just 3D printed a skull, and I think it's 100% regular size. So like, I think it's actually bigger than my skull. So, but it looks really, really cool. You get to see kind of inside here with like the brainstem and all that stuff. So I thought this was really cool, and this is what made me want to make this video today because I really wanted to make a video talking about how vision relates so closely to the brainstem here, and all the information and nerves that kind of come right out of here, and how close that actually is to your eyes, which is only inches away from each other. But you think about it in a slightly different way, because you're like, my eyeballs are up here, my spine is back here. How could that possibly happen? But everything is kind of in the middle there, so you only got a little tiny distance. Anyways, we're not going to focus on that today. We're going to be focusing on the process here, from step one to kind of the last step here. And they could be broken down even further, but I'm just going to go through about 7 to 8 steps today. So first of all, the light entry. So obviously light is going to come into your eyes, right? And everything that's coming into your eyes right now is light. And your pupils, the little black dot in the middle of your eye, are going to adjust depending on how much light is coming through, basically. So is there a problem with that? Is there a problem with light coming through your pupils here and not reaching your retina properly? Seemingly, no. I mean, you do have some people complaining about their pupils not adjusting properly or light sensitivity. So if you have light sensitivity, maybe your pupils are too dilated all the time, or maybe you have another issue somewhere else that's causing that light sensitivity. But that doesn't mean that the issue of visual snow or visual snow static is coming from too much light coming through your eyes. So we just have to say, no, that cannot be the issue. That cannot be the problem. Next, we go to the lens and the focusing. So obviously, it's going to go through your lens next. So that's the thing that focuses things, kind of like a little piece of glass, or obviously a contact, or glasses. If you have problems with your lens, you just need glasses. Or contacts. It's as simple as that. So, is there a problem with that causing the visual snow? Almost certainly not. How? That would be absurd, but I guess I could leave it open for like the 0.01% chance, maybe, but no, just no. So, then you get to the back of your eye. All the light is traveling through this weird fluid in your eyes, and that's where the floaters are. It's called vitreous fluid. And that's where the floaters are. So if you're wondering where the floaters are coming from, like, is that part of visual snow? Well, all those things are in there. With visual snow, it's weird because people don't know, and nobody knows the answer here, whether or not visual snow causes you to have more floaters or just notice the floaters. It seems like it's probably just notice the floaters, but from personal experience, it seems like I actually got a lot more floaters when I got visual snow syndrome, which was really weird because at the very beginning, within the first month or so, I didn't have that many floaters. It took me a couple of months to actually get to see all those floaters, which was, again, just goofy for me, and I had abrupt onset, so I have a somewhat unique view on the situation compared to the lifers. So the static, is it coming from something in the vitreous fluid existing there? Almost certainly not. That's what floaters would look like. So I just got to go with a big fat no here again, guys. Like, it's not causing an issue, but we can understand a symptom again. We can understand those floaters. And then it gets interesting. This is where things actually get kind of complicated. Before this, we're like, okay, life makes sense. But then once you get to the back of the retina, the light is going to hit your cone and rod cells, and that light is going to be turned into electrical and chemical energy. If you really, like, when you first think about it, you're just like, okay, well, yeah, Chris, like, I mean, obviously, I've taken basic biology. I know what cells do. But then when you really think about it for, like, a quick second, you're like, okay, light never reaches my brain. But I understand what light is. I understand what's going on here. So, like, your brain is making up what you are seeing by saying you are seeing light through these chemical processes in the back of your retina. It's kind of absurd. It just is. It's like, when you really think about it for like a quick second, it's absurd. But anyways, I completely understand how things can go wrong in this process already. I'm like, chemicals turning into things. We just kind of rely on them to just do their job all the time. And they seemingly almost always do, except in the rare visual snow situations. But anyways, when they hit the rod and cone cells, they're all going to, you can't just send all, I don't even know what you have, hundreds of thousands of cells, millions of cells, all together in one random thingamajig. You have to bundle them up. So you bundle them up through these things called ganglion cells. And there's a bunch of different ganglion cells for different things. For example, some of them do like center of your vision, high resolution stuff. Some do some like outside vision type stuff. Some do like some blue yellow contrast stuff, and obviously a lot of other things as well. But could there be an issue with the ganglion cells? That's a question. It's a real question, and the answer is probably not. And the reason why is because if you have issues with your ganglion cells, you probably have a much bigger problem than visual snow. You probably have like a really bad glaucoma or neuroretinopathy where you just can't see anymore, kind of at all, like blindness almost, or close to it. So visual snow, not blindness, probably not ganglion cells here. And if it was an issue with that, it would be unlikely that you would have them in both eyes, because you would have just an issue with one eye or just the other eye. At this point, we have not merged them together. So extremely, extremely, extremely unlikely anything going on with the ganglion cells. But again, I would leave that 0.0001% chance of maybe something going on with them. But it's probably like just a random like connection thing rather than them causing the issue itself. So then we get to bundling the ganglion cells even further into our optic nerve. Okay, now we're getting somewhere. So if you had an issue with your optic nerve, what would happen? Well, if it was just a minor issue, probably not that much. You might just see things a little bit wonky or something. But if it was a major issue with your optic nerve, you'd probably have blindness. You probably couldn't get any of that information to the back of your brain properly, and you could become blind. The interesting thing about this is, again, it would be in probably one eye, because they have not merged yet. This information is just in one eye each. They have not merged yet. So if you had an issue with just an optic nerve, it would be one eye going blind, or one eye having static, or one eye having issues. It's, again, unlikely that it happens to both eyes, to everybody, every single time. Just very unlikely. Possible, something going on where inflammation happens on both sides or whatever, crushes both nerves at the same time or whatnot. Okay, causing issues in some way. Yeah, maybe, but again, extremely, extremely, unbelievably unlikely. Like, just no, you'd probably have way, way, way more problems than a static at this point. So we're going to say probably not the optic nerve. And then we get to the optic chiasm, which is the optic nerve sort of crossing over itself. And this is the part of the brain somewhere in the middle of your brain here, basically. It's going to cross over, and it's going to give you 50% of your information to one side of the brain and 50% to the other side of the brain, and you merge them together so both eyes can work together now. If you just had one eye going to one side and one eye going to the other, then you wouldn't be able to have your eyes work very well together, So this is a problem, by the way, with visual snow, is that a lot of people say that their eyes don't work well together. So optic chiasm, slight issue, maybe. But don't forget that the brain is not just a one-way road. It's not just sending information, light and information down one way. You got some back and forth here. Obviously, more information is going to travel one way than the other. In the situation specifically, we want to get the information from our eyeballs to the brain. But you don't really need to send information from your brain to your eyeballs all that much. Like, you don't need to understand what you're seeing with your eyeballs. You just need the eyeballs to do their job, which is to send the information backwards. So So, but your brain is going to talk to your eyeballs. It's going to tell them to, move and change pupil size and all that other stuff. So, something you don't even have to think about, by the way, which is kind of nice. You don't have to think about changing your pupil size to make them larger or smaller. If you had to do that, that'd be kind of absurd. Or if you had to think to make your heart beat, that would be absurd. So it's kind of nice that a lot of these things are just automatic. We don't have to think about it at all. But either which way, optic chiasm. Is there an issue with this guy? Well, again, it's extremely unlikely because if we did have an issue with the optic chiasm, we'd probably have larger issues than what we're currently having. We'd probably have vision loss in some way. Or the way that they work is they're kind of crossing over each other. So this is where you get weird half vision loss. Like you lose half the vision all in the middle here or half the vision all on the side here. And that's clearly not happening. So optic chiasm, just no, probably, almost certainly not. So we've gone through a lot of steps so far to say almost certainly not a problem with any of these. And then we get to a very specific part of the brain, something called the thalamus. Now, the thalamus in general is just a lot of sense data coming in. This is where it gets weird and fairly complicated. And to be honest, a lot of it is way above my pay grade. But I'll try to do my best here to try to explain it in a little bit of detail. There's a little bulb on the back of your thalamus called the lateral geniculate nucleus. And believe it or not, keep in mind that the thalamus is still a thing, and there's going to be two of these bulbs, right? There's not just one. And again, because the visual information is crossing over, and 50% went each way, and now the information is going into the back of your thalamus, so you can finally start to understand what you're seeing. So far, it's just been sending information. You've not really done any processing yet. Just sending information. It has to send it very quickly. It has to somehow have you be able to basically see and understand what is going on almost instantaneously. If we were seeing things from 2 or 3 seconds ago, there's no way anything would ever get done, right? It's just wouldn't we just all die in a blur of nothingness? Things have to happen very quickly, otherwise it's just kind of ridiculous. So the lateral geniculate nucleus is a little bulb in the back here, and again, there's two of them, and it has, for the most part, a layer of cells. I forget exactly what they're called, pyramidal cells or something like that, and there's 6 layers of them, and each one of these layers does different things. And what's weird about it is it's still separating your eye data. So, I know eye data, it's kind of weird, but it's still separating it. This is your left eye stuff, this is your right eye stuff, and it's sending it one on this side and one on this side. So they're separating the information still. They still haven't merged it together in any meaningful way. But it does a lot of weird stuff. Again, it does processing, for some minor processing here, of motion, brightness, spatial resolution. It can deal with color and spatial resolution, color processing. And this is interesting to me because when it comes to color processing, that's also a contrast thing too. And when I specifically got my first, when I got Visual Snow, one of the most interesting things about my Visual Snow was the increase in not only light sensitivity, but the increase in contrast. I got a crazy increase in contrast. Now, if you go to Photoshop and you just turn contrast up to 90-ish%, maybe 100%, that's about what I saw. And I know specifically because when I was first getting Visual Snow, one of the shows that I watched the most was South Park. And South Park, if you actually look at it, it's just a bunch of really bright colors. The floors and the walls are really bright colors, and they just stick out like a sore thumb. And when they stick out even further when you've got crazy contrast up. I literally was like, whoa, this is intense, man. So you have issues with contrast, color processing, and obviously brightness as well. So, and possibly motion. Which, guess what? Those are all Visual Snow problems right there. Okay? Brightness. A lot of people have sensitivity to light. Some more extreme than others. Motion. We see motion blur. again, not all of this is necessarily coming from the thalamus. It could be from other places leading to the thalamus or from the thalamus leading to the brain. We don't really know yet, but this is a very key spot that a lot of people want to talk about because it's like, dang, all the original, the OG processing is happening in this area right here. And if you just have these small sets of cells get screwed up in some way, dang, bro. So, believe it or not, one of the most popular theories is that there's something called thalamocortical dysrhythmia, which is your thalamus and your cortical areas of your brain, the rest of your brain almost, have a dysrhythmia. They are not rhythming properly because you have these. You've probably heard of brain waves, right? And the way that the brain talks to each other is it often sends big groups of stuff together. So you have these waves basically, and if you have an issue with the waves, they're not sending properly, you can have like a mismatch in things and you can get messed up, and that's what might be leading to the visual snow and all of the other issues. At least that's kind of like a base part of the theory here, is that the dysrhythmia of all the rest of your brain talking to the thalamus is getting screwed up and causing issues. So again, is this proven? Absolutely not. Absolutely not. But does it make sense? Yes. It makes a reasonable amount of sense that somewhere in the thalamus, specifically the lateral geniculate nucleus, has issues going on. Now, there's also, interestingly enough, other senses in the lateral geniculate nucleus, or the thalamus, and right next to that is another area that deals with hearing. So if you hear a lot of other people say that they are sensitive to sounds, or have like extreme sensitivity to sounds. I forget what the name of it is, but extreme sensitivity to sounds. Some people think that, they're just so close to each other. If there's actually an issue going on here, maybe there's an issue going on in a spot right next to it. Maybe. I don't know. Can't say for sure. But that's definitely an interesting thought process, right? So what does this mean overall? I mean, again, probably there's something going on with the thalamus. Probably. Now, the question is it the thalamus then sending all the information to the next step? So the next step is visual processing. This is where your brain is going to process all the information so you actually understand it. Now, this is, again, the weirdest part out of all of it, and way, way, way above my pay grade, because it's not just like a line. You send it to this area, then you send it to this area, then you send it to this area, then you send it to this area. It's literally all these areas talking all at once, so you physically understand what is going on with your vision. There is processing going on to tell you what is happening. Like, for example, all the stuff that gets sent to your brain is actually upside down, but you randomly process it to be right side up. What? If that's never something you've never heard of before, it's true. It's ridiculous, but it's true. So, like, your brain does all this processing for you, and helps you understand what things are. For example, if you have problems with certain parts of your visual processing, you might be able to not see faces. Like, faces don't exist for you. They might just be like a blur almost, because you have a very specific part of your brain that deals with processing faces in particular. That's why we have, like we see faces in like tree stumps or, random places where faces don't exist, because like there's a very specific spot in our brain that's like, look for faces, look for them. So again, you're sending the processing of your vision to all these different areas so you can read, so you can understand what you're seeing, and saying that that's not just like an object, that's a zebra or that's a chair. Like, you need to understand what it is. So this is why it's so freaking complicated, because you're not just seeing something. You're seeing and you're understanding something. So you have to process all that information, and it just goes to all the different areas all at once, and it kind of is what you are. It is you, and you have to have an emotional experience with all of that. So it gets really, really wild. So this is where things get confusing, because so far we've been talking about everything from the bottom up, so to say, from the bottom up, from the base of the information coming in. But what if now that we're talking about the visual cortex and all the other complicated parts of the brain here, what if the problem is actually from the top down? So what if the problem is, for example, you need to understand what you're seeing. You need to have an emotional aspect of what you're seeing. You need to have the part of your brain that controls the senses a little bit, actually sending information back to the visual cortex, back through to the thalamus, and those are what are screwing things up. And what if those parts of the brain are also partly your consciousness? So your consciousness is the top-down thinking. Okay, now I know we're getting deep right now. We're like, whoa, 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 Chris. Top-down thinking. This is our emotional selves here. All the thoughts and feelings that we are sending that information down through the visual cortex into the thalamus, and all of that in some weird way is screwing up our vision. It's a strong possibility. In fact, this is one of the leading theories by a lot of the researchers right now. So I'm actually going to just read this really quickly. I think I got it down here somewhere. I have some notes here. The analysis showed that VSS patients had reduced functional connectivity in the serotonin networks of the visual cortex. So serotonin networks, it's just a specific neurotransmitter. And you see this because oftentimes people have issues with SSRIs that lead to visual snow, or have anxiety or panic attacks that lead to visual snow. And that might be an issue with serotonin for some reason. Not sure why. But serotonin networks in the visual cortex, the insula, the temporal pole, and the orbital frontal areas of the brain as compared to healthy controls. So there's a lot of different areas of the brain. And again, that's sort of just the top-down areas of the brain here. So the question is the issue going from the thalamus to the visual cortex and out to the other areas, or are the other areas sending the information back down to the visual cortex and through to the thalamus that's causing the issue as well? It could be a combo factor. It could be kind of both of them just connecting together in a wrong way, and that's what's causing the issue. It could be just the top-down approach, or it could be the bottom-up approach. Not really sure. But somewhere in the middle of all that is what's going on. And that's the most complicated and weird part of visual snow, and that's why nobody knows what's going on, because it's your entire brain. Right? Not your entire brain, but like a big chunk of your brain here. That your emotional experience of yourself, your consciousness of yourself. I mean, like, how do you explain that? You know, it's near impossible. So, anyways, let's continue reading this really quickly. Compared to the healthy controls, this reduced connectivity in the serotonin networks. This reduced connectivity in the serotonin networks was also seen in migraine patients. Specifically migraine patients with aura. Guess who gets ocular migraines, or used to get them quite a lot, and guess who got visual snow and a big chunk of like a dozen ocular migraines all within about 2 weeks? This guy right here, man. Oh crap, would you look at that? It's all connected. So with aura suggests a biological link between visual snow syndrome and the aura itself. You see this, it's very, very common. Sometimes people are perfectly 100% healthy, and they get a random ocular migraines here and there, where they just see zigzags or weird rainbow things, and they usually only last like 30 minutes. Some people get them once every couple of years or whatever. That's what happened to me. I used to get them every couple of years or whatnot. And randomly, I kind of had a bad, stressful time where I got COVID, and I got stomach problems all at the same time, and boom, I got a bunch of ocular migraines right in a row, and during those ocular migraines, I got a blind spot, and during that blind spot, I got visual snow. So that's what happened to me. That's just kind of my nutshell experience right here. But anyways, let's continue reading this really quickly. The findings suggest that the serotonin activity in the VSS patients may be influencing the integration of the complex sensory information. So they're saying specifically that serotonin issues are causing the connections between the different parts of the brains to not work properly, which is causing the visual snow. That's all they're saying. That's what it makes sense. Another interesting aspect of the study here. This is an important study from King's College here, one of the most important ones, by the way, that I have actually seen overall that actually gives you information about visual snow. And it says that the results did not find any differences between the brain chemicals that were investigated in the study, for other brain chemicals that were investigated in the study. So serotonin and glutamate were the only ones where they saw any issues whatsoever or any changes whatsoever. So nobody knows. Nobody knows the answer. But this is seemingly the some of the major theories, that the top-down approach is more likely than the bottom-up. At least that's what the researchers think. And that's actually kind of intriguing because that is something that may be able to be resolved with transcranial magnetic stimulation. If you can actually see these parts of your brain that control those visual areas, and you can change or alter the way that these things are connected. So that might be a very reasonable treatment to do for people. It may be very complicated to do. It may make things worse, but it may make things significantly better for a lot of people, specifically if they get good at it and stuff. So I think a lot of people are looking for drugs to fix this. I like to think that because the different parts of our brain aren't connected properly, we need to fix those connections somehow, hopefully with the stimulation and knowing which areas to fix over here. Will end up being the saving grace for people. Who knows? Don't know the answer for sure. It could be a complete shot in the dark. It could just be a garbage shot. But that is my biggest hope at the moment for a complete fix of it. But I have other ways to get it to feel like a back burner approach, and I'm going to give you guys some of those anxiety-reducing techniques and neck stretches and things like that eventually as well. So, again, I'm not an expert on any of this stuff. I do my own research. I have my degree in biology, so I at least have a background in this kind of stuff, at least basic stuff. And I guess the last thing I'll talk about here is the anterior cingulate cortex is one of the big areas that is often kind of overworked in visual snow people. And that is one of the big areas that controls the top-down control over the sensory inputs. So it's like, holy crap, it keeps coming up. If you ever look at a lot of the research, which I've read, I think, almost every single research article, I can't remember it all, obviously. But one thing that really pops up here is the anterior cingulate cortex, which, like, it's actually really, I think it's a really small part of the brain, too. It's like a very small thing. It seems like it controls a lot of stuff in your brain. And if it controls the sensory inputs and it controls the top-down approach of the sensory inputs, then it can just mess up the entirety of the situation here. So if we could just fix that little tiny area, maybe we can fix everything. Maybe. I hope, at least. So I think that's really all I got today. I tried to dumb down the idea of light coming through your eyes, to eventually turning into electrical signals, to eventually going through your brain in different ways, and eventually coming out as you yourself understanding what you are seeing. Where is the area that is messed up and all of that? Nobody truly knows, but it seems like it's probably either the somewhere in the thalamus, the lateral geniculate nucleus, specifically of the thalamus, or possibly it's an area in the higher order part of the brain that is sending the information incorrectly to the rest of your brain that is causing the issue. Or lastly, it could be, again, that they're not connecting properly, whether it's overworked or underworked or whatever. And all of these could be an issue with so many different things, it's almost impossible to tell. There's a lot of theories out there, and a lot of people are looking at neuronal reasons, like you have too much calcium or too much, I don't know, potassium or whatever. They're like, the potassium channels are messed up or whatever. And it's really, 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 really difficult to say anything about that because, like, even when you're doing, like, like some research on mice and stuff, like, yeah, are you really, like, looking at each individual cell and knowing which one's messed up with all these different things? It's really difficult. So you kind of have to guess with drugs with this kind of stuff. And then even if you do guess with a drug, say, well, this drug helps, right? Because it lowers calcium in this part of the brain. Like, does that really mean that is fixing the issue? Or is that just part of the issue is being somewhat hopefully randomly resolved from the other things that it's kind of connected to? So it's really, really difficult. Again, to say that anything is caused by anything in the brain, it's often so many chain reactions and interactions with each other that it's just like it's so complicated. It really is a ridiculous organ, and understanding it is so complicated that it's almost absurd. But anyways, it's more likely that it seems to be a total network issue, connecting issue in your brain, rather than a specific neuron problem. Or a specific problem with your actual brain, like a problem with too much of this chemical or too much of this protein or too much of this something in your brain. And then that is possible because sometimes those connection issues can cause issues or differences in with the way the brain works. But specifically, it seems like serotonin is the big issue here, possibly also glutamate. Any which way, if you guys enjoyed, press that like button for me. I'd appreciate it. Feel free to leave any comments below that, let me know any extra information. You can tell me your story or whatever you want to tell me, and I'll try to figure this stuff out together. Thank you, guys, and we'll see you next time.